Hey everyone, welcome back to the Take It Apart channel where we dissect everyday items so you know what they look like on the inside and maybe a little bit more about how they function. And today we are going to take a look at a very casual object indeed. I'm talking about power strips. Now in my other channel, the Better Biomed Channel, we discuss power strips, but I don't take them apart and show you guys what's the inside. See, there's a whole different variety of power strips out there, from very casual, the ones that are very light use, you plug something in once and then you forget it, and then there's the commercial grade ones which are expected to have a rougher life. You know, people are plugging stuff in, pulling it out, it has to have a certain amount of plug retention. There's a lot of electrical code that kind of goes into some of those, and I bet you a lot of you guys didn't know that. So let's get right into it. Let's take a look at power strips. Okay guys, today we're going to take a look at, well, let's start it off with this guy, all right? This one here is a very easygoing power strip. It's fabrique in China. This one's got some good pluses though. Take a look at the plug. It's an offset plug and it's flat. Now some plugs have like a little commutator in there and they allow you to rotate the plug assembly. This one doesn't. It basically offsets it because it's hanging down at an angle. You know, it's a pretty good plug, especially in close proximity if you're going to back a piece of furniture up against the wall. Instead of having the 180-degree plug where the cord comes straight out, this one here comes out, goes down at a 90-degree, and then it's offset. So instead of dangling straight down, it goes down at an angle. That way there you can put multiple plugs in a line. Because if this guy was dangling straight down and you plugged it in, it would probably block the next plug or the next receptacle. So, it's got some pluses. It's got a flat cord. Flat cords, I actually dig flat cords, especially in a home environment. They're reasonably durable, and the fact that they lay flat and nice and neat, whereas the rounded cords, they kind of like to coil up and go all over the place, don't they? It has another unique feature. It's got a little hook. So you can actually hide this guy in, clip it on something, and hopefully it stays. I use zip ties on these guys, so if it's going to be like under furniture, let's say I have a couch that plugs into the wall, which I do, you put something like this underneath the couch, and then you zip tie it down so it'll never go underneath the foot, because squishing damage is definitely an area where you're going to affect these guys. It has 3 different 15 amp receptacles on it. It's very typical. Let's see, this guy here is 16 AWG. Alright, 16 gauge. Pretty good. Pretty reasonably good. This guy, I have a couple of them throughout my house. Not too bad. It's not the cheesiest, cheapest cord out there, but at the same time, it's a low profile and it's not the most expensive. Can't really dissect this guy without using a saw because there are no fasteners. It is sealed, hermetically sealed. It's molded. Alright. That's the first one. Let's move on into regular household grade. And this is an IKEA brand. And let's see. It has a unique trip. Almost like a GFCI or overcurrent protection. Interesting. I don't know if I definitely don't like that. That drives me crazy because it's always on. See that? It never goes to off. That's weird. Here, I'll let you guys see what that profile looks like. That's off right there. It never flicks off. That's weird. Alright. So this one here has 6 outlets, 15 amp. And it's just regular, let's see. It says clamping voltage 400 volts. Okay, so it does have some sort of circuit protection. We're going to find that out. 15 amps maximum, of course. Has a very short cord. Good on them. Seems to be a pretty large diameter, so that means it's going to be, what, 16 gauge? 14 by 3. Oh cow, okay. 14. That's actually not too bad. IKEA, you're doing something right. Let's go ahead and take it apart, guys. Let's see what it looks like on the inside. I'm actually pretty curious. They've done a lot of things right so far. Screws are not so large. Coming out pretty easily. All plastic screws. Notice on the back of this guy has 4 mounting holes. So it's just 6 fasteners. Not too bad. Alright. In an everyday household power strip, what does it look like on the inside? Okay. Interesting. We have our little breaker / power button down here. What else do we have on this bad boy? Got the little fluorescent indicator. No, that's an LED. We got a little LED because over here I've got a rectifying diode, and we have what looks like a mauve metal oxide varistor. Oh, right there. It's got internal fuse. Interestingly enough, it says 5 amp 250 volts. Okay. It's right there. Interesting. What is that guy connected to? Wow. Some of this does not look so good. Take a look. I don't know if this camera's going to pick it up. Come on, camera. Alright, let's zoom in a little bit. You can see a little bit of garbage going on right there. The conductors are very poorly soldered, and what it is, there's a through hole on that switch, and they twisted some of the conductors, or they didn't twist them at all, and they crammed it. Whatever stuck in the hole is what they soldered, and what just sprawled out when they tried putting it through the hole, they just left it. So there are conductors that are all over the place. Yeah, that does not look good at all, guys. So here are the receptacle bus bars. And the receptacle bus bars are a thin brass. Was not expecting anything different. And when it comes to the ground, it's just a pretty thin plate that's clamped. All of the cables are soldered to the bus bars. Yeah. Nothing too major there. Pretty simple. And it's all separated by little thin pieces of plastic, so if it gets hot at any point, it's going to melt and it's going to have a catastrophic failure. Which there are many photos, not necessarily of this model and brand, there's many photos of these cheaper household power strips failing and melting, and now you see why. It's because of the close proximity, minimal shielding, stuff like that. Bare bones, guys, bare bones. Alright, next. This one here is possibly a slightly better quality. This is a 125 volt 15 amp. Has a proper on-off button this time, guys. But this one is also a surge protector. So it should trap or trip this guy. We're going to find out. We'll find out. Maybe we'll compare and contrast the internals of one power strip versus the other. Just wait till we get to the commercial grade ones, folks. Just wait. Bare minimal electrical code in order to make these ones to market. Now the last one had 4 hangers. This one only has 2. Okay. That is a little bit better. Let's see, where's my other power strip? So what they did is by orienting the plugs in a different direction, for one, they make more clearance so that, as we said before, you plug one thing in and the next one's going to be like right on top of it. This one here, they space them out a little bit better. They put 5 receptacles on this guy versus 6 on this one. You guys know, like, you never really fill the 6. Never really happens. Oh, interesting. There's some bugs that are falling out of it. By orienting it differently, you are placing the ground and the ground's down here, and the hot and neutral further apart. So the actual distance between the hot, which is up here at the very top, the neutral and the ground, it's much further apart than this one. Look at how close they are on this one. I mean, if I were to place it all the way in, there's just a thin piece of plastic right here that's separating the two and keeping it from catastrophic failure. This one here, there is at almost all times a half a centimeter between each of the conductors. It's pretty good. So this one has got maybe a slightly thicker grade brass than the first one from IKEA, and the blade terminals are way better. So on the IKEA, you can see how they have a punched piece right here. Let's see if it gets it better when I zoom out. Probably not. Grr. Okay, on the IKEA, we have just a stamped piece right here, which is pushed out, and it's bowed. So when the blade plugs in, let's see if I can simulate it. So when the blade plugs in sideways like that, there's contact. Oh, there you go. There's good contact. Not the best. Definitely not the best. In this one here, they have longer and thicker electrodes that are pinching together. I would say that this one here is going to last way longer than this one. This is one of those where you plug it in once, like behind your computer, and you leave it. Hopefully it's not the highest current load. I don't think I'd ever trust this one at 15 amps. Never. No way. This one here, this is more reasonable. All the wires are looking pretty neat and tidy on this guy. That's good. And notice how this one has a circuit board versus this one just has, what is this guy? Hold on. This one does have a fuse, but it's not for what you think. It's not really a circuit protector whatsoever. And I want to pull this board out, but it's being really fussy. Is it pressed in? Come on. I think they squirted like some Celastic up inside there. I could see what looks like a mauve. Mauves are used for surge suppression. Yeah, that's like glued in there or something. Really difficult to show you guys. But it does look like there's some metal oxide varistors. The wires are neatly soldered down. I don't have any of that frayed wires. Even here where we have through panel, you can see that they twisted it nicely and they soldered it, and then they stuck it through the hole, and then they resoldered it. The bottom side of the surge suppressor board, nice healthy clumps of solder. No cold solder joints. One of them right here is almost suspect, but no, they actually did it pretty good. That's a very generic surge suppressor power strip. Oh boy. Interesting. What a drastic difference between the two of them. Now, I know going forward, I'm not going to ever buy the ones where it's one plug and then another plug right on top of it, because I know they're going to use almost that same design philosophy. And that design philosophy is pack as many of them in there with a stamped piece of brass, and I do not like that at all, guys. On the back side of these, there's some pretty healthy standoffs on each of them. And there's definitely better yank protection on the second one than the first one. There are 3 little clefts that kind of hold on to the cord. This one here has got 2 V grooves. Aren't as good. The ones with the notches will really get into that outer insulating jacket and hold on to it. So yeah, it's overall better built. So now we're going to get into commercial grade power strips. And one of them is an oldie but goodie right here. This one is everywhere. Hopefully they're starting to get phased out. you know that it's a medical grade because it has green dots, which are clearly not showing up. You can see on the plug it says medical grade, and the green is on there someplace. But just trust me, folks. See, there you can see the green dot, and on this guy here, they also have green dots here and here. So this is a medical grade power strip for when it was created. I do not believe that this guy meets code whatsoever anymore. Medical grade power strips are the best of the best. That means they're very heavy duty. Modern day ones have double breakers, one for hot and neutral. This one here only has one single breaker. It's all metal casing on this particular one. Regular full size receptacles like you'd find in your house. If I open this up, these are going to be regular receptacles like I would find in my wall. So they are the real deal, folks. And to open this guy up, we have to take two of the screws off here at the end caps. And today I'm going to be using my fancy dancy brand new Craftsman screwdriver here. I just did a video on this over at the Better Biomed YouTube channel, and it seems to be a real treat. And it's reasonably strong. I didn't think it was going to be so strong. Like a champ. These are screwed directly into the extrusion. Yeah, that's an extrusion. And I figured they'd probably come out a little tough. Not an issue at all. So the two end caps have two Phillips, #1 Phillips screws. You have to take those off. And then the two extrusions will mate together on a rail. So it kind of clamps together. See that? You can see the rail that I was talking about right here. It's actually part of the extrusion. You can see the profile. There you go. So they do kind of clamp together. We can just pull it apart, or you can slide it down the length. Can't slide it too far though, because we have that integral breaker and we have this cord strain relief still there. You can slide it that way though. Because it's a metal housing, classic of the 80s and 90s and even the 70s. Who knows how old this guy is? Maybe I'll find a date stamp. They used to put like this cardboard in there as flash protection, you know, to keep those conductors, just in case something happens from touching the metal outer case. That's what they used to do. It is what it is. We have a properly screwed down ground, and that ground goes to a series ground for both the proper receptacles up here, as I said earlier. The cables are screwed down proper. They are not soldered anymore. We have one terminal right here, one spade terminal for the incoming power cord. Have a through panel 15 amp breaker right here. And all the other cables are done beautifully. This is back when people really took a lot of pride in their products. This power strip, I have no idea what brand it is. You see them all over the place, and some people throw them out because they're not meant to be in hospitals anymore. However, they are still extremely good power straps. Let's see. 3x14. Okay, so 14 gauge. Excellent. 15 amp receptacles, 15 amp NEMA plug end down here. It is a 90-degree NEMA plug. Good for them. Hospital grade plugs have a very particular orientation. They have a proper distance from the outer edge to the conductors, so that minimizes the chance that you're going to wrap your fingers around it and get electrocuted. And there's a certain quantity, certain quality of strain relief and yank relief built into the plug end. And this one here is a very nice 90 degree. Notice how it's an inverted 90 degree. That is because in hospitals, receptacles on modern day medical facilities are inverted. So the ground conductor is at the top. This one here demonstrates that perfectly. So when you plug it into a wall, it sits at its native angle instead of being inverted and putting all that strain on the side of the cable like that. They inverted the plug. Good on them. And I believe that this guy here, in some of these old school ones, you can flip it around manually. You have to take the screws out, flip it around. I see everything's done really beautifully. I really dig that they have a clear receptacle or a clear plug-in, because you can take a look inside and you can still see how tight the fasteners are, and if the cable's starting to get strained or if it's been overcurrented. Overcurrent, it'll start to discolor, and along with the plastics around it. This one here is pretty nice. I really dig this. You don't see plug-ins like that anymore. Good on them. First, medical grade. That's an older one. Now let's open up a modern day medical grade. This one here is a trip light. Now this one here also doesn't comply with the latest and greatest code, which, like I said, latest and greatest code has a breaker on both the hot and the neutral. This one here only has it on the hot. And let's see, what standard is this one on? This one does not say what standard it's part of. I can tell you for a fact, this guy is exceedingly heavy. It is all metal case, proper receptacles, just like the last ones, which are marked with the green. But this one, it says antimicrobial coated. Trust me, if you got microbes on your power strip, you got bigger problems. This one is much heavier, and I'm really curious, because normally when they're this heavy, there's like a transformer or something inside it. So let's, without further ado, let's open it up and let's see why is it so heavy? Trip Light does make some of the best power taps, relocatable power taps on the market. You can see medical grade molded plug. This is 180 degree, unlike some of the other ones which sit flat against the wall. So this one here, being a heavy power tap, you have to worry about this type weighing down on the plug end itself. These on medical grade plug terminals, they are solid. They're not folded over like some of the cheaper ones. It's got proper strain relief. A very short cord on this one, notice that. And that's because this one would probably be located inside a cabinet or on a rolling cart. Yeah, this one's going to be really close proximity to an electrical outlet. It's going to be mounted. There are tabs where you can drill this here and here and put a fastener through it so it's properly mounted. It says that it is UL listed. Doesn't surprise me. This is a particularly expensive power tap. I'm actually looking at the UL sticker right here to see if I can see what electrical code that is compliant with, and it doesn't say. Now all the newer modern day ones will say their standard that they comply with, which I have an example of one of those right over here. I'll be more than happy to get that for you guys. Okay, alright, and these guys, they not only have fasteners, but they also have these metal clips. There you go. You can see that there's little inserts. What is this? What is this? Okay, alright. Interesting. On the back of this medical grade, there are two mounting holes, and there are multi-directional, so you can either mount it horizontally, vertically, whatever. I love those. Here's the thing. They did something extra special. They put covers over those to minimize fluid intrusion coming into that, and also to limit how far in the fastener can go. Because if you've got a fastener that you're hanging this on the wall, let's say you didn't screw it all the way in, you got a fastener that's like that long, which I've seen, it can only go in so far. See that? It can't come all the way in and accidentally archy spark on a terminal. Some people screw things straight in the wallboard, which is drywall, and anybody that screwed something directly in the drywall knows that with any wear and tear whatsoever, it likes to pull loose. Those fasteners would pull loose, and they would eventually work their way in here where there's live circuitry. Can't have that in a hospital now, can we? So they put guards over them, covers with Kapton tape. I dig that. Really nice. Okay, 15 amp breaker on the hot only. Neutral is in series between all the outlets, and man, look at these bus bars. Look at those buses. Here's one, all in series. Very nicely done. This is a premium power strip, and it exemplifies that absolutely. All the grounds down here are terminated together, soldered together to the chassis. So the entire chassis is grounded constantly, and the back cover also has a ground redundant. Man, those buses are really nice. They use solid core conductors, by the way, in their buses. Solid core. That's like the same kind that you would see in your wall, versus some of the older ones. You can tell that these are not solid. These are flexible. See those? Solid core. Those are rigid. Dang, very nice. Okay, so there's those two. Let me get you guys the absolute latest and greatest. Okay, this one has been gifted to me by Triplite, and I'm going to share it with you guys. All right, guys, here it is. Now, mind you, yes, Triplite gave me this one. However, this power strip right here, I'm not receiving any payment, and Triplite has no idea I'm making this video. So, when I say that something's a good product, it's because I'm supporting it. I use them every day anyway. This is the latest and greatest from Triplite. Incredibly heavy duty. This one here is a medical grade. It doesn't have the green dots on the front. It does have the coating, as it said, on the back. And the way to know that this one is a medical grade is it says on the tag on the back. And let's see, what is the code that this guy follows? It's a new code, by the way. Notice on this guy right here, it is a flat plug, so it goes and it takes the entire receptacle. So the entire 15 amp receptacle is going to be taken up by this plug. Now, why would you do that? It's because it has redundant ground. You see that? So you don't have just one ground up here, you have two grounds. And look at the diameter of this cable. What is the wire gauge? It's 12 gauge. Oh, no, it's 10 gauge. What? It says that there is one 12 gauge wire. Yeah. I think the ground is a 10 gauge and the other conductors are 12 gauge. There's two different codes written on the shank right here. Hospital grade. Very cool. It's E5200401. Is that the new medical code? E522382. Anyway, I wish I knew what electrical code this one was compliant with. Electrical codes are so confusing, especially when you get into medical facilities. This is the latest and greatest, though. I really wish I knew what the code was for this guy. I'll look it up, and I'll include it in the video description down below. You'll have a link where you can find this and the other Triplites. It has a disclaimer on the side which talks about, electrical shock, yada, yada, yada. Notice how it has these covers on them. These covers require a tool to open. So, yeah. They do that to limit fluid intrusion, and also if you have things like children or whatever, you don't want them just poking stuff in electrical outlets. So that's why you have these shields that snap over, and they require a tool to open. Very cool. You can remove those with these Phillips screws if you want. Has the same tangs where you can screw things in. Very cool. And let's see. Let's open it up. After all, this is the Tear It Apart channel. Let's see what they do. Oh. Is that a number 2 Phillips? Okay. Oh, dang. All right, come on, Phillips. It is a number 2. Okay. In that case, they stepped it up a little bit. Go. Same metal tabs that hold it closed. Just pop those. All right, they have some extra things in this one. Nice, nice, nice. Notice they have the flash protection like the other ones did. They have the solid bus bars, just like the other one did. Look at the size of those ground cables. Oh my gosh, this is such a beast. Holy cow. Okay, so this one is high potential tested. It has redundant ground inside it. Okay, so that's why I didn't understand. So it said that there was what, three conductors of 12 gauge, and then there's one conductor of 10 gauge. That right there is your one conductor of 10 gauge. It's that massive ground that's coming out of that cable. See it down there? There's 2 ground cables inside this. So you got 3 conductors, your normal hot, neutral, and ground of 12 gauge. You have one 10 gauge, this beastie guy right here. Holy cow. That is a well-grounded outlet for sure. And there's a very firm stake right here with all the eyelets for all the ground cables. Very cool. All the outlets are also firmly screwed down to the chassis. This is extremely nice. Very good strain relief here on the through panel. Good stuff. And this plug-in, you're never going to destroy this plug-in. Sits neatly against the wall, and it's got this built-in ledge right here, so that when it is plugged in, you can imagine there's going to be quite a bit of retention on this. That way there you can get your fingers on there, get a proper grip, and then you can pull it off. Very nice. I dig it. Okay guys, so that's a quick look, not so quick look, into power strips from the residential grade all the way up to the latest and greatest commercial grade. And you can see that there are some proper differences between them. And maybe you don't need everything in your power strips. Maybe it's going to sit behind your computer and pull low amperage. Maybe it's going to be in a commercial hospital environment with wet locations, and you need a power strip that can handle the daily abuse of a hospital. So guys, there you have it. Power strips in a nutshell. Thanks for watching, guys.